From railways that cut through mountains to giant bridges spanning vast rivers, from architectural feats buried deep underground to transportation systems built for the future. Over just a few decades, China has turned ideas once considered impossible into infrastructure that is actively running today. In this episode, we bring you 10 extreme megaprojects that push engineering to its limits. What is it like to build a railway on moving geology? The Sichuan Tibet Railway cuts through the rugged southwest of China, often described as a sky road, and it is widely considered one of the most complex and difficult rail projects on Earth. The route is about 838 kilometers long and crosses the Hengduan Mountains and the Tibetan Plateau, where terrain is extreme and engineering margins are thin. The difficulty comes from elevation swings of more than 4,000 meters, plus a constant mix of threats, earthquakes, avalanches, debris flows, permafrost, and rock bursts that can make tunneling feel like the mountain is fighting back in real time. To make the line viable, about 81% of the route is bridges and tunnels. So large stretches run either underground or high above deep valleys. On the Yan to Nainchi section, tunnels such as Erlengshan and Goligongshan are often treated as world-class benchmarks. The Erlengshan Tunnel, for example, is about 13.4 kilometers long and has to cut through fractured rock while also dealing with high temperature and high pressure conditions, which pushes construction into a near maximum difficulty zone. Even so, progress has moved forward step by step, with engineers solving one hostile constraint after another. When the full line is completed, the Chengdu to Lhasa journey is expected to drop from roughly 36 hours to about 13 hours. That change is not only about speed, it reshapes connectivity across the plateau, strengthens links between Tibet and the interior, and offers valuable lessons for high-altitude railway construction around the world. Hidden deep in the mountains of Hubei, this bridge in the clouds once held the title of the highest bridge in the world, and it is still among the tallest suspension bridges on the planet. It spans the Siduhe Gorge in Bailong County with a main span of 1,100 meters, and the deck sits about 560 meters above the valley floor, roughly the height of a 200-story building. Look down from the deck, and it feels like you are floating above a sea of mist, with the gorge opening up in every direction. Building a suspension bridge in a gorge this steep and remote creates one brutal question. How do you get the first pilot line across to the other side when heavy machinery cannot even reach the site? The construction team solved it with a move that sounds like science fiction: rocket launch technology. They fired a thin guide rope across the canyon with precision, then used it to pull progressively thicker cables into place. It was one of the first high-profile cases in China where aerospace techniques were adapted directly for bridge construction, a true infrastructure flex. With high-strength main cables and a deck designed for seismic performance, the bridge is built to handle strong winds, heavy rain, and earthquakes. After opening, it turned a multi-hour mountain detour into a crossing that takes minutes while also becoming a must-stop landmark for road trips because the view is unreal. If the earlier projects chase altitude, this one goes the other way. The Shanghai Shimao Quarry Hotel is a rare architectural spectacle that transforms an abandoned quarry into a luxury destination. And National Geographic has described it as a world architectural wonder. The site sits in Songjiang, Shanghai, inside a former rock quarry about 88 meters deep. It is widely noted as the only luxury hotel of its kind built into a quarry wall. From concept to completion, the project took about 12 years and pushed through a long list of engineering headaches. The quarry walls are steep, and stability was the first battle. Teams spent years reinforcing rock faces, using rock bolts, shotcrete, and other slope stabilization methods to reduce collapse risk before the main structure could move forward. The hotel steps down the quarry wall across 18 levels, with 2 levels extending below water level to create underwater rooms and dining spaces. Guests can look out through floor to ceiling glass and watch the underwater scene at the quarry bottom, with fish moving past like a private aquarium. Throughout construction, the project leaned hard into the idea of ecological restoration, blended with architecture, preserving parts of the original industrial quarry character, while adding greenery and water circulation systems to turn a scarred pit into a living landscape. At night, the lighting traces the building lines like a modern castle carved into stone, reflecting off the water and turning the whole quarry into a cinematic set. Chongqing Raffles City is not just a handful of towers planted on a riverfront. It feels more like a bold move at the exact point where 2 great rivers meet, where the city basically nails an elevated street straight into the skyline. The first look feels familiar for a reason. The project comes from the same design mind behind Marina Bay Sands in Singapore, architect Moshe Safdie, and that signature idea is instantly recognizable. Lift everyday city life up into the air and let the skyline become a place you can actually inhabit. The feature that steals the spotlight is the Crystal Sky Corridor. It bundles 3 things into one piece of infrastructure: a high-altitude viewpoint, a retail circulation spine, and a city-scale landmark. It runs roughly 500 meters, about 6 meters wide, and reaches around 200 meters above the ground at its highest point. Walking across it, the view below is pure Chongqing, river surface far beneath, highways twisting and stacking, traffic flowing like a living diagram. Above the city haze and shifting light do the rest. And the whole place can feel like a 3D model of the city unfolding under your feet. This is not only a photo stop, it translates Chongqing wild terrain into a kind of wild urban interface. And it answers one very simple question with a straight face. Can a road live in the sky? In Chongqing, the answer is written across the horizon. How do you cross a 335-meter vertical cliff in 88 seconds? The Bailong Elevator, recorded by Guinness World Records as the tallest outdoor elevator, turns a risky mountain trek into a near-instant ride into the sky. The project cost about 180 million yuan, which is roughly 26 million US dollars. The system is anchored into the mountain with a vertical shaft about 154 meters deep, while a steel-structured tower about 172 meters tall is fixed in place using more than 4,000 anchors and 15 large anchor cables. 3 double-deck panoramic cabins run side by side at speeds up to 5.25 meters, moving as many as 6,000 people per hour. Since starting operation in 2002, it has reportedly transported more than 60 million riders and helped drive a major jump in visitor volume at Zhangjiang. What used to be hours of road or hiking can become an 88-second ascent, making the elevator feel less like a convenience and more like a symbol of technology meeting wild terrain head-on. This is the showpiece of the Three Gorges project. The Three Gorges Ship Lift, often described as a vertical elevator for ships. It tackles the core navigation bottleneck around the dam by moving vessels up and down efficiently, and it represents top-tier capability in hydraulic engineering and heavy mechanical systems. Located on the left bank of the dam, the maximum lift height is about 113 meters, roughly the height of a 37-story building. The ship chamber is about 120 meters, long 18 meters wide, and 3.5 meters deep, designed to carry vessels around the 3,000-ton class. The chamber plus the water inside can exceed 15,500 tons in total weight, comparable to a massive warship-scale load. And lifting that smoothly is the whole challenge. The process is tightly controlled. A vessel enters the sealed chamber, gates close at both ends, and a computer system coordinates hydraulic drive and a gear and rack climbing mechanism to raise or lower the chamber in a steady controlled motion. What once could take half a day for dam passage is often described as being reduced to around 40 minutes. During construction, teams had to solve large load control, high precision positioning, underwater sealing, and protection against extreme conditions. A gear and rack climbing approach paired with counterweight energy-saving design helps reduce operating energy, while multiple emergency locking systems can secure the chamber during major events such as earthquakes or floods. The long development timeline is commonly described as spanning more than 2 decades of technical work, with a large number of core breakthroughs and several performance metrics reaching record level. Operationally, it enables 3,000-ton class vessels to move more directly toward Chongqing, lowering shipping costs and strengthening the Yangtze Economic Corridor. This giant lighthouse is often described as the first tower-type molten-salt concentrated solar power plant designed for continuous 24-hour electricity generation, marking a major milestone in renewable energy engineering in China. The site covers about 2.9 square kilometers and centers on roughly 12,000 heliostats, a solar receiver tower about 220 meters tall, and a molten-salt thermal storage system. Visually, it looks like a futuristic lighthouse standing in the desert. The core concept is elegant. Thousands of mirrors track the sun in real time and reflect sunlight onto a receiver at the top of the tower, heating molten salt to around 565 degrees Celsius. Compared with standard solar PV, the big advantage is thermal storage. Heat captured during the day can be stored in molten salt and released at night, allowing electricity generation when the sun is gone. The plant leverages strong solar resources in Inner Mongolia, with annual generation described at about 198 million kilowatt-hours, enough to supply electricity for nearly 100,000 households. It offers a template for dispatchable renewable power that can behave more like a conventional power plant. Marketed as the first large-scale artificial mountain-style building, this pyramid-like structure challenges the flat, stacked logic of conventional towers. The concept is architecture living with nature, aiming to create an urban man-made mountain range in the middle of a city. The project is described at about 100 meters tall with total floor area above 200,000 square meters. Instead of simple vertical stacking, the massing rises and falls in layered terraces that mimic natural mountain contours. A signature feature is a series of giant structural columns that extend outward like enormous planters, carrying thousands of trees and tens of thousands of plants across the facade to form a dense three-dimensional ecosystem. The idea is that each column becomes an ecological support system. Vegetation can capture dust, improve air quality, and help regulate interior temperatures, while also supporting a lower carbon footprint through passive shading and evapotranspiration effects. Visually, it evokes a modern hanging gardens vibe, and conceptually, it argues for a future city that feels greener and more breathable, where steel and concrete become a host for living systems. In a dense city like Wuhan, surface space is already maxed out. Roads clog, and digging new metro lines can be expensive and disruptive. The solution here is to go upward. But with a twist, a suspended monorail known as the Optics Valley SkyTrain, described as the first commercial suspended monorail line in China. It looks like a transit system borrowed from the future. The track beam is elevated on columns around 5 to 8 meters high, and the train hangs beneath the guideway, running above chaotic traffic. The system is electric and uses automation heavily, aiming for efficient operations with reduced noise and a lighter footprint than many ground-level options. Design elements such as transparent glass flooring turn a normal commute into a full-on aerial viewpoint experience, letting riders look straight down at the city as they glide past. Beyond novelty, the system represents a different way to free up urban space. Fewer conflicts with intersections, less intrusion at street level, and a new layer of mobility that makes the city feel more open. This is a station built on megascale. Chongqing East Station, located in Chongqing, is described as one of Asia's largest rail stations and a major integrated transport hub in western China. Total floor area is about 1.22 million square meters, roughly the size of 170 standard soccer fields. The planned platform and track layout is 15 platforms with 29 lines, covering high-speed rail, conventional rail, and intercity services. The design capacity is often described as up to 50,000 people waiting at once, with peak hourly passenger dispatch capacity around 12,000. The defining feature is multimodal transfer, designed to feel seamless. Underground levels connect directly to multiple metro lines. Ground level includes long-distance bus connections, local bus hubs, and taxi zones. The interior also leans into smart systems plus natural lighting and ventilation, paired with green landscaping elements. According to the description provided, the station began operations in June 2025, and it aims to reset expectations for what a modern transport hub can look like in a mountainous, high-density city. After watching these breathtaking feats of engineering, which one impressed you the most? Let us know in the comments. Don't forget to like, subscribe, and we'll see you in the next episode.